This coming Monday, day after tomorrow, will be the 40th anniversary of the launch of Apollo 10. So 40 years ago today, we were in the pre-launch phase for Apollo 10, getting ready to go to the moon. And this afternoon, we're going to start off with a movie that will put you back in that frame of mind of the people of 40 years ago. And then we're going to have Glenn Lunny, who was the lead flight director for the Apollo 10 mission, say a few words, and he'll answer all the questions you have on the flight. So without any further ado, if this works, we'll get the movie underway.
May 18th, 1969. We were almost ready. Man had orbited the moon once. Man had test flown the lunar module, the lunar landing craft, in Earth orbit once. But before we would commit men to a lunar landing, there were still a number of things to be worked out. This was the mission of Apollo 10. In the words of its commander, Tom Stafford, to sort out all the unknowns and pave the way for a lunar landing. It was a veteran crew. Spacecraft Commander Tom Stafford had flown on Gemini 6 and 9. Lunar Module pilot Gene Cernan had flown with Stafford on Gemini 9. John Young had been on Gemini 3 and Gemini 10. They would face problems on Apollo 10, problems that would be solved for Apollo 11. Most would be minor, but they would be solved. Stafford, Young, Cernan. They brought to their mission enthusiasm, dedication, responsibility, even amazement. And through the means of color television, they took us with them as they played their part in man's greatest adventure.
We are go for a mission to the moon at this time. Tom Stafford reports they are go. We're coming up in the 20-second mark. T-minus 20 seconds and counting. 17 seconds and counting. Guidance internal. 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. Engines on. 5, 4, 3, 2. All engines running. Launch commit. Liftoff. We have liftoff 49 minutes past the hour.
Roger. Good ignition on the second stage.
Man, that staging was quite a sequence. Just like old times. It's beautiful out there.
You guys sound ecstatic.
Man, this is the greatest journey.
Apollo 10 was headed for its initial parking orbit around the Earth. After the checkout in orbit, it was time for TLI, Trans-Lunar Injection, the burn of the S-4B engine to send Apollo 10 to the moon.
7 minutes, carry up.
Roger, 10. You're go for TLI. S-4B's looking as planned.
Right on. Seco!
Roger, Seco. We confirm the cutoff.
Apollo 10, with a perfect burn, was on its way to the moon. Now, the command and service module separated from the S-4B and turned around to dock with the lunar module. For the first of many times, Tom Stafford turned on the small, high-resolution color television camera and shared with the people of Earth the spectacular sights of outer space. Apollo 10 took along all those who had made and were making the conquest of the moon a reality.
Charlie, we can't be more than about 5-10 feet away.
Roger. 10, it's looking real stable to us. We show you closing slightly.
Roger. Be docked in a second, I hope.
Roger. 10, Houston, you're looking good. We can see the markings in a rendezvous with it. It looks like you just docked.
Roger, we got a capture. You haven't fired yet.
Roger.
Snap, snap, and we're there. Got 2 grays.
Roger.
You saw the docket, Charlie.
Gene, we can read the numbers on the LEM docking window.
During the docking, Apollo 10 encountered its first problem. The mylar containing the insulation on the spacecraft hatches had broken, releasing a snowstorm of fiberglass in the zero gravity.
Hey, we're going to have a heck of a cleaning job here. They had insulation all in the seal, all in the valve, and it is really a heck of a mess up here.
For Apollo 11, it would be fixed. Then we watched as they pulled free of the S-4B and got our first live color pictures of the blue planet Earth.
Charlie, this is it's so hard to describe. You can go right up past Alaska and you can see the polar caps. It's incredible.
Well, we see it all here, Gene. Its colors are really beautiful.
That's great. And the blackest black that you ever could conceive is the setting for all this.
Right.
So Stafford, Young, and Cernan began their coast away from Earth, their speed continually dropping as the arms of Earth's gravity tried to pull them back. To control the temperature of the spacecraft, they performed a slow, steady rotation.
Yeah, it sounds like shortly we'll soon be about 55,000 miles out, huh?
Yeah, that's right.
Sounds like a long way from home, Joe.
It was time to continually check the trajectory and the spacecraft. The command module, call sign Charlie Brown, the lunar module, Snoopy. It was time for conversation, and it was time for showing the people at home on the Earth what space travel is like.
And I'm sure for one time you have your choice. If you don't like things right side up, you can go upside down. I just do whatever he says.
Roger, down here. Okay, we got one of you in each direction.
That's the only way to fly.
Farther and farther from Earth, Stafford, Young, and Cernan flew on their wingless flight. Now, off the rotating home planet, day and night became only a progression of minutes as the spacecraft rotated at 3 revolutions an hour.
We're about to finish that ambulance thing, and we're going to psych out. Today and tomorrow we should be around the moon.
Roger.
Reveille, up all hands, heave out, price up. Clean sweep down, fore and aft.
Apollo 10, Houston, sounds like we're ready for a naval drill in the flight deck.
And here is your horoscope reading for today, Apollo 10. Tom Stafford, you should concentrate on finishing things that you have already started. Today's pace will be moderate. Use this time to take inventory. John Young, you will have a slow day today. This will give you time to concentrate on the work ahead. You will enjoy your surroundings and companions.
And Gino, your horoscope reads, give careful thought to your working and driving habits. Do something nice for your friends.
The crew of Apollo 10 was getting ready for lunar orbit. Checklists gone over, clocks synchronized, computers updated. As the time for the lunar orbit insertion burn neared, the men in mission control concentrated on their displays.
Houston, Apollo 10, just tried looking out as far as I can out of the top hatch window and still can't see the moon, but we'll take your word that it's there. Over. It's there plus 60 miles.
No guarantee on that.
Apollo 10, Houston, 2 minutes, LOS. Everybody here says Godspeed.
Okay, and we'll see you right on the other side in orbit.
Roger.
LOS, loss of signal. The burn to place the spacecraft into lunar orbit would take place behind the moon, out of contact with Earth. Later, a second burn would make the orbit circular, 60 miles above the moon. The flight controllers waited for AOS, acquisition of signal.
We have AOS.
Hello, Apollo 10, Houston, over.
Roger, Houston, Apollo 10, you can tell the world that we have arrived.
How's the view, 10?
Charlie, it might sound corny, but the view is really out of this world.
For the second time, 3 Americans orbited the moon. The electronic senses of Misfin, the manned spaceflight network, followed their flight, measuring precisely their orbital path. Information vital to the success of the first manned landing. On the first orbit, the crew turned the TV camera on the scarred lunar landscape.
See a crisis up here. That's the first real thing I'm positive of that I've seen that I recognize, and boy, it really stands out.
Stafford, Young, Cernan, 250,000 miles from Earth, 60 miles above our desolate satellite.
Boy, this is really a rugged planet.
But also looking out at the horizon and some of the mountains we can see down here, that's going to be a real kick tomorrow down at 50,000 feet. Over.
We copy that.
Hello, Houston, Apollo 10. We've got a beautiful view of the Earth here, but it's absolutely fantastic.
Now it was time for Lunar Module pilot Gene Cernan to crawl into the lunar module called Snoopy to check it out for the next day's descent. His evaluation?
And I personally am very happy with the fella, and I hope we can give you as good a report tomorrow.
You bet your life.
Hey, you watch Snoopy well tonight and make him sleep good, and we'll take him out for a walk and let him stretch his legs in the morning.
Oh, okay.
The next day, Stafford and Cernan were in the lunar module, John Young in the command module called Charlie Brown. They checked out Snoopy for the last time. One of the items involved venting the tunnel connecting Snoopy and Charlie Brown to make sure that the spacecraft hatches did not leak.
Roger, I say again, we cannot get the tunnel to vent, over.
Right, I understand. Tunnel will not vent.
This was a real problem. The vent pipe seemed to be clogged. However, the hatch integrity was checked by reducing the pressure in the lunar module. The inability to reduce pressure in the tunnel also caused a 3 1/2 degree rotation between the two spacecraft. Not enough to endanger undocking, but for Apollo 11, it would be fixed.
Okay, Charlie Brown and Snoop, 3 minutes going over the hill. Your go for undocking, and we'll see you around the other side.
Roger.
Roger.
The undocking took place behind the moon. When contact was re-established, Snoopy and Charlie Brown were ready for the separation maneuver prior to descent. The word from John Young and Charlie Brown was,
You'll never know how big this thing gets when there ain't nobody in here but one guy. You'll never know how small it looks when you're as far away as we are.
Hey, John, if you get a chance, you can turn on the radar transponder and we'll correlate the VHF ranging with it.
Okay, my transponder is on. Transponder is on and the test switch is in operate.
I should be getting a radar signal here, and I sure don't.
an electronic piece of radar equipment in the command module was not functioning. Without it, there would be no rendezvous and no low-orbit descent in the lunar module to the moon. In mission control, and in the two spacecraft, switch positions and procedures were rechecked. For the descent and subsequent rendezvous were the heart of the Apollo 10 mission. From Mission Control, one last-ditch instruction was sent up.
Roger. How about trying to recycle the power switch, Charlie Brown?
In the command module, Young turned the switch off, then on again.
Hey, that did it, you guys. It's on.
Hey, and I got signal strength, though, buddy.
What do you know about that?
A little thing, a stuck switch, but for Apollo 11, it would be corrected.
Okay, Jose, say adios, and we'll see you back in about 6 hours.
Right. Have a good time while we're gone, babe.
Yeah, don't get lonesome out there, John.
And don't accept any TEI updates.
Charlie Brown, Houston, 45 seconds to LOS. You're still go for DOI.
DOI, Descent Orbit Insertion, would come about 180 degrees from landing site 2, the primary site for Apollo 11. According to the inexorable laws of celestial mechanics, this burn of the lunar module descent engine would put Stafford, Cernan, and Snoopy less than 10 miles above the site. Once more in Mission Control, they waited for word from the moon.
Houston, Charlie Brown. They're down there among the rocks, mumbling about the boulders and things right now.
8 miles above the surface, 35,000 feet over the ancient hills. Then a communications problem. Contact with Snoopy was reestablished through Charlie Brown.
Hello, Houston, this is Snoopy. Right, Snoop, go ahead. We is going, we is down among them, Charlie. Roger, I hear you weaving your way up the freeway.
Roger, fantastic, Charlie, fantastic.
Roger.
Charlie, babe, that's fantastic, babe, really.
We just can't believe what we're seeing. I tell you, Joe, this satellite of ours, this moon of ours, had a rough beginning somewhere back there. I tell you, we're down here where we can touch the top of some hills, though.
Then, one of the key aspects of the mission. Tom Stafford describes the landing site selected for Apollo 11.
Yeah, okay, the approach end looks a lot smoother than some of the orbiter photos show. It's still estimate 25 to 30%, a semi-clear area, so if the LEM has enough hover time, at least from what we can see at 50,000 feet, it should not be a problem. Or if you come down in the wrong area and you don't have the hover time, you're going to have to shove off.
Now it was time to begin the rendezvous. On this first low orbit, they would make the initial burn to put Snoopy and Charlie Brown into the proper phase relationship for the coming maneuvers.
Okay, we're burning, John, we're burning.
Snoopy was now ready for the rendezvous sequence to be performed on the next orbit. Once more, they rounded the battered face of the moon.
Oh, Charlie, we just saw Earthrise, and it's got to be magnificent. Charlie, I don't know how the big man must see things, but if his view is any better than ours, it's got to be fantastic.
Before the actual rendezvous burns took place, the lunar module's ascent stage would have to be separated from the descent stage. But during the separation, something went wrong. Snoopy began to roll rapidly.
Get out of there, babe. That's that last attitude. Snoop, Houston, we show you close to Gimmellock.
Yeah, okay, something went wild there on that station.
And we're all set. We didn't lock it. We're going ahead to the autumn.
Charlie Brown, Houston, they got staging. They had a wild gyration, though, but they got it under control.
It was an unexpected system malfunction. Stafford and Cernan quickly had it under control. In fact, Tom Stafford and Gene Cernan were never in any kind of danger, but for a few seconds, they didn't know that. For Apollo 11, it would be found and corrected.
Now the rendezvous sequence came step by step. It was old hat for the veteran crew. In Gemini, Stafford had flown 5 rendezvous, Cernan 4, and Young 3. So Snoopy rose up from the moon to join Charlie Brown.
Hey, Joe, we're about ready to dock. Stand by.
Okay, John, you're into about 5 feet, mate. Looking beautiful. Hello, yes, Snoopy and Charlie Brown are hugging each other.
Roger that. We heard him down here.
But the day was not over yet. They still had to prepare the ascent stage and command module for their final separation.
We're all back in the command module. The tunnel's all locked up, and we're in attitude and standing by the SEP here when you give us the word.
We can go ahead and separate now, Charlie Brown.
Okay, Houston, we'll give you a countdown. We're all set to go for SEP. Give you a 5 count. 4, 3, 2, 1, fire.
Dan, when he leaves, he leaves. Yeah, it was right into the sun, babe. Right into the sun. Actually, like Tom said, there's a lot of people who did a good job, and I tell you, these vehicles so far, that little Snoopy was a real winner.
We concur.
That big Charlie Brown is no slouch either.
The next day, Apollo 10 stayed in orbit around the moon. The orbital deviations of Apollo 10 were being determined with greater and greater precision. On board, there was more photography, more landmark tracking and navigation. With each revolution, the figures were being pinned down closer and closer in preparation for the arrival of Apollo 11.
Joe, Jack Smith, there's some very interesting looking things that sort of look like volcanoes. There's one on the backside that if it was in a different setting, you could call it Mount Fujiyama.
I saw.
But now it was time to head home to Earth. Trans-Earth injection. The one burn of the mission that absolutely had to work. The burn that would push Apollo 10 out of its lunar orbit.
Everything looks good for TEI.
Roger, we'll go here, and we'll see on the way home.
Again, this most critical of all maneuvers would take place behind the moon, cut off from earthly contact.
Roger, Houston, we are returning to the Earth. Over.
Glad to have you on the way back home, 10.
For the last time, Apollo 10 watched the sapphire called Earth rise over a stark lunar horizon. And as they had throughout the mission, Stafford, Young, and Cernan shared with us the sights and feelings of their voyage through color television.
You guys are really hauling the mail out of there.
Oh, you better believe it. It's like we're climbing straight out, Joe. It's a fantastic sight. It's like we were shot straight out from the center of the moon.
You're going about 6,000 feet a second.
As the crew of Apollo 10 hurtled earthward, they decided to perform one more test. A test not in the original objectives of the mission, but a test that would solve a problem that had baffled space engineers for years.
Somebody finally came up with the idea of using a razor and brushless shaving cream.
That's amazing, 10. Absolutely. That's what the space age does for you.
I tell you, Charlie, that's one of the most refreshing things that's happened in the last couple of days. That was really great.
You guys really look good.
Down from the moon toward the coast of Earth, Apollo 10 sped on its incandescent path toward its dawn rendezvous at sea. Problems had been met, faced, and solved, for that was the mission of Apollo 10, to sort out the unknowns and pave the way. But as the men of Apollo 10 were reunited with their families and friends, attention was already turning elsewhere. Apollo 11 had been rolled out to its launch pad even before Apollo 10 had entered orbit about the moon. Now it stood, pointed toward a distant lunar sea.
How much we're going to progress in the future is left to your imagination. But if we harness our energies and keep our perspectives right, the goals are unlimited.
Well, that was about 40 years ago. And we have with us Glenn Lunny, who was flight director for that flight. Glenn started with NASA when NASA got formed and worked on the Mercury program and was a flight director on Gemini and Apollo. And then also became manager of the, as they say here in the U.S., the Apollo-Soyuz test project. And in Russia, as they say, the Soyuz Apollo test project. So we flew that successfully in 1975 and then became the shuttle program manager in 1981 and then left NASA in 85 to go with Rockwell and had a very successful career with Rockwell and then took over space operations in Houston, operating the shuttle and also getting involved in the space station and retired from United Space Alliance. So let me turn it over to Glenn Lunny.
Thank you, George. You know, the picture of the Saturn V, if there are any people in the room that haven't been to a manned launch, we have a few more of the shuttle, I would urge you to go see one. There's something primal, at least for me, about seeing them launch. Maybe it's imagination. You know, humans are leaving the planet, but it's a powerful feeling. A couple other explanations of what you saw. You couldn't tell it and nothing was said, but the Saturn V ride in this particular case was rough for a couple of reasons for the crew. They really were rocking and rolling in the cabin during that flight, and enough where they were actually concerned about it, especially when they were doing the burn, TLI burn, which is translunar injection, the final burn to put them on the way to the moon. Next, when they were approaching the moon, it was dark the whole time. And you might have picked up that somebody said something about that. They hadn't seen the moon actually until they got right down, perhaps after the burn to put them in orbit around the moon or very close before that. That was not planned, but it was probably a very good thing, because if they could see the moon getting bigger out their window and realize that we were targeting them for 60 miles behind it, I don't think they would have believed it. I just don't think they would have believed it. No way. But they didn't see it, so they didn't worry about it, and it came out exactly at 60 miles. The other thing about the shaving, NASA, true to its tradition of gadgets, you know, we tried all these electric shavers, and the hair from the shaving would get loose in the cockpit. And, you know, it would make a mess in the filters and so on and so on. And somewhere along the line, as they commented, somebody said, well, why don't we try shaving cream and straight razor? And the cream kept the hair contained and put it in the towel, and there you were. It's a great flight. One of the problems that we had was we had so many great flights back in those days, and they were stacked up usually about 2 months apart. And there was no time to enjoy it, because by the time you get off the console, and for us, we worked on almost every flight. And by the time we got off the console in the control center, it was time to get ready for the next flight. So we had to start forgetting about that one, paying attention to the next one. And we never really had much time to savor the flights that we flew and the things that happened and so on at the time. We did some later, but one of my friends likened the pace we were on to having the chug-a-lug fine wine. We never had a chance to enjoy it. We drank it too fast, and you know what happens then. The other thing about looking back, and I've noticed this when people get together to talk about it, or when people have written a book, they tell various stories in the book. It's surprising how many things happened that no one person knew all about. And so when you read it, you say, oh boy, I didn't know that happened. That got by me. I didn't know it. And it reminds me that history is really in the eyes of the beholder. It depends on your perspective. I happen to have the one I did, which was as working here in the Houston Center, working on all the flights. I worked in the control center. I had the best job in the whole world, and I did it for about 8 or 10 years in the control center until I got promoted out of it. And it was a grand time. But we see these things from a slice of the world. So I'm going to talk about some of the things I saw. But had I worked somewhere else in the system, had I worked at the launch site, or where they built the rockets, or the contractor plants, I would perhaps have a different set of stories to tell you, but no doubt equally interesting. So I would look back, and perhaps today, since we're limited on time, I would just give you an idea of what, from my perspective and my knothole on the Apollo program, were the primary reasons why it was as successful as it was. I guess I would start with a motivation. People were very highly motivated to do well on the program. They viewed it as a national imperative, and one that the country did not want to fail in. So I think everybody came to the program and came to work every day with this sense of national urgency and a need to accomplish the imperative that had been laid out for us by John Kennedy, President Kennedy, in 1961. So that was there all the time. It sort of pervaded everything that we did. One of the primary things then for making it work, given that attitude, was the fact that the hardware that we got from the contractors and from the government engineering teams that supported the contractors, the hardware was extremely good. It really was good. I mean, that machine you just saw, I don't know how many parts it had, too many to count. But for the most part, it worked pretty well. We had redundancy in a lot of cases that we had to rely on at times, or at other times we had problems that had to be worked around. When we were flying the Mercury and Gemini spacecraft, they were a generation earlier than what we flew in Apollo, and we had a fair number of problems with the equipment that we had. The thrusters would clog up; they would not work right. The fuel cells generate water, and it goes over in tanks just to store it or even to drink it. But in Gemini, for some reason, the water didn't always go in the tanks. It stayed in the fuel cell, and the fuel cells gradually flooded, and the power that they could generate gradually went downhill. So the Gemini flights at times were a race with our planned end of mission, with either the fuel cell flooding or the thrusters clogging up and not being able to work anymore. But all in all, the Apollo hardware, for the most part, was extremely reliable, and I'd have to give that credit number one for how the program turned out. Number two, we were blessed, I mean truly blessed, with the leadership that we had available to us. Early in my life, I came to appreciate the value of real leadership. People who can see what they need to see and help steer a team of people to follow that path and get to the right place. I have also seen, by the way, in 40 years since, circumstances where leadership is not very active or is actually pretty bad, and it's just terrible what that can do to a team and an organization. It's just a shame to watch that happen too. But we were blessed at that time. We had terrific leadership. We all aspired to model our behavior and our actions after the leaders that we saw, and never did fully succeed in that, but we had at least a model for what we should be, and that's what we tried. The third thing I would mention is a little bit lost in at least the recountings of history. What I will try to explain is, when we flew Mercury, we had 4 manned orbital flights. By even Apollo standards, by today's standards, the spacecraft was relatively primitive. Relatively simple equipment, mostly all analog, no digital equipment on board to speak of. No ability to maneuver the spacecraft around in orbit and change the orbit. We could maneuver the spacecraft and put it in different orientations, but we couldn't maneuver it. We had a retro rocket pack, which solid rockets fired all at once, brought us back to Earth, so it was a form of maneuvering, but it was the only one on board the ship. Flew 4 times. We then had a program called Gemini. It was a 2-man spacecraft, and it was intended to be a bridge between 4 manned flights in Mercury, really pretty simple, not doing very many operational things in space, and the Apollo, which was going to demand a great deal from us. Gemini was designed to up the crew numbers to 2, to use a digital computer, rendezvous radars, landing radars. Didn't need a landing on Gemini. We had to experiment with different types of rendezvous. We had guided entries back to the planet when we had after the deorbit maneuver. We did EVAs. We docked with another stage in orbit called the Agena, much as you saw the crew having to pick up a lunar module and get back into command service module when they came back up. We had to perfect that, and that was perfected during the Gemini program. We did rendezvous every way you could possibly do one. I never stopped to count them. We probably did a couple dozen rendezvous tests while we were in the Gemini program. So 4-man Mercuries, which hardly prepared us for Apollo, except some sort of a sense of confidence that if we had enough time and enough flights, we could figure out how to get all the rest of it done. When we got to Apollo, there were just a handful of manned flights before we landed on the moon. Walt's flight, Apollo 7, Walt Cunningham's flight, was the sine qua non for getting to the moon. First vehicle, it was a low Earth orbital flight, 10+ days. The CSM had to work. And by that time, the program had evolved to the point where, at least in privacy, there was discussions about taking the next flight to the moon on Apollo 8, because the lunar module was delayed and it wasn't going to be ready on time. So Apollo 7 going very well in October allowed the decision and then the public release of the fact that we intended to go to the moon on Apollo 8 in December. It was going to go on the Saturn V. We weren't going to take a lunar module. And at first we were just going to fly by, but the more we thought about it, the more we became convinced that we ought to go in lunar orbit, stay there for a while, do all the navigation that we could do in order to know how accurately we could do that to set the crews up for landings on subsequent flights. Christmas Eve from the spacecraft was as memorable a thing as I can remember in Apollo. Apollo 9, then the lunar module became available. So the big Saturn V that Tom flew on here, Tom and the guys, put the lunar module and the CSM in orbit, and we did a whole bunch of rendezvous testing between the 2 ships in Earth orbit. That was Apollo 9. So we'd flown 3 flights up till that point. Apollo 10 then came up, and the decision process went something like this. We hadn't yet flown Apollo 10. We hadn't yet flown the lunar module in lunar orbit. It's not clear that there's anything dramatically different, but certainly some of the guidance stuff and other things were different. And as a matter of fact, we didn't know whether there were some unknowns that we hadn't uncovered yet in the lunar module, having only flown it really one time manned, that is on Apollo 9. The other thing about the lunar module is it was a little bit on the heavy side. They had been through these weight reduction programs, and the lunar module was a little bit heavy. There's some dispute. Some people think it might have been adequate, that is light enough to fly with the gas we could put in the tanks, land, and get back up okay. Others thought that was much too marginal to trust the first landing to a set of conditions that would have been very precarious in terms of running out of fuel at the wrong time. So Apollo 10 was decided, and we went to the moon on Apollo 10 to do everything that we possibly could do to set ourselves up for the Apollo 11. You got a flavor of it here. They were on an orbit that went over the landing site. They mentioned something called mass cons. We found when we first flew there, and maybe people knew it before that, but I first heard about it, there apparently were local gravitational anomalies from great big whatevers plunging into the surface of the moon and going down beneath the surface, and they perturb the orbit. And normal course, that doesn't mean too much, but when you're setting something up where you're trying to land it fairly precisely, like we were doing Apollo 11, and on Apollo 12 we landed next to a previous surveyor site, that is an unmanned vehicle that had been landed on the moon. So we were interested in being able to land close to where we wanted to land, because that would improve the odds of being able to conduct the scientific excursions and the explorations that we had in mind doing. But nevertheless, on Apollo 11, it was a safety of flight thing. We wanted to be able to navigate as well as we possibly could, and knowing how these mass cons, concentrations of mass, affected the orbit were important to us. So for those kind of reasons, but probably primarily the one about the LEM being a little bit on the heavy side, it was decided that we would do Apollo 11. We young Turks would argue with the boss, saying, well, as long as we're going to go that far, why don't you let us land? The adults won the conversation, and we did what we did. So in 4 flights, then we did everything that we had to do to decide and to be sure that we were ready to do Apollo 11. Apollo 11 was the 5th manned Apollo, landed, and the rest of that is history that you know all too well. But the reason we were able to go on the pace that we did on Apollo is because in Gemini, the team of people who, from my perspective, the team of people who planned the missions, that is the mission planning guys who figured out all these things about how you do burns in orbit and how you would abort to come back and how you would land on the moon. That was the planning team, and they were absolutely tied in with the folks that I worked with, the flight control people in the control center, because we were the guys who had to take this theoretical descriptions of things and turn it into something that you could actually monitor and watch and program the guidance computers to do. And then, of course, the astronauts. The astronauts came through Gemini. We flew together 10 times, mostly testing the things we needed to have in our hand when we went back to the moon. And both the bonding that occurred of people struggling with flooding fuel cells and all the other things while still accomplishing all their objectives, and some of the problems that we had, which were even more serious than that, brought the team together to the point where by the time we got out of Gemini, we were very competent in Rendezvous, very competent in using digital equipment on board the ship. We were very competent in steering the ships where we wanted to go. We had an excellent planning team, which had now done the same sort of planning for the Apollo environment. We had some EVA experience, which, by the way, was a surprise to us in some ways. We did not know how to do EVA as well as we thought going into Gemini, and it took a couple of painful experiences to realize that and to get it back on track. It turns out that it was more difficult to arrange the EVAs successfully when they were in space, where you would think it would be easier, but we found that with the addition of the 1/6 gravity on the moon, doing the EVAs was much like doing them here on Earth. It was not as difficult. The problem with the EVAs when you're free flying in space is that it's awful hard to maintain a position. It's easy to get bumped off and float away from where you're trying to be. We didn't appreciate that going into Gemini, but we sure learned it very well. And we learned how to put handholds, footholds, how we looked at traverse paths so that there was a set of ways for the crew to work their way back to the back of the ship or wherever they were trying to get and make it work. So when I look back on that, you know, and those of us who were there at the time would tell you that the experience that we had in Gemini allowed us to be rather bold and rather confident about a very short, almost minimal set of flights, what you might call test flights, precursor flights to landing, that we were able to perform, and then we were comfortable that we could get on with the landing when its turn was up, and we did. It was a grand time. It was a grand time. I read the books that people write now, and I haven't written one, and I think about it myself, and looking back on it, it has the color of gold. You know, it's kind of a golden haze around what we did, and it was it's kind of great to revisit them again. I love looking at the old films. So with that, a little summary of Apollo 10 and how it fit in and what some of the credits were. But let me go to questions. George, do you have one? No, he's... Yes, yes. First one to stand up. Go ahead. I can. Oh, I see. Here it comes. Yes, yes. We were having to go through this, so everybody knows.
Dave Williams. My question for you is the achievements over a 10-year period in the 60s were truly remarkable. And nowadays, of course, we're looking at leaving low Earth orbit, going back to the moon and on to Mars. Our risk management strategy today seems to be very process intensive. And I'm wondering if you can comment on the leadership and the willingness to accept risk and the unknown challenges of spaceflight, how you approached that back in the 60s relative to today, where sometimes we need procedures to go and change a light bulb on the space station.
Yeah. It is true that it appears to be that way, and we certainly characterize it that way even in our own conversations at times. I know a lot of the people who are in the program. As a matter of fact, our youngest boy is a flight director in our youngest son is a flight director in a control center now, and he's going to be he's on this flight, and he's going to do ascent descent on the next one. And I know that young people who are doing this, and I know the young people who are in the Constellation office planning for the next mission. And I have to tell you, they're an admirable group of people. At times, for example, in the last few months, they have been without an administrator, and I have felt bad for them because for 4 or 5 months here, they have not had air cover, to use a military analogy. They've been out, in the trenches doing what they have to do, and they don't have much air cover in Washington, D.C., and they need it. They need it. They ought to have. They deserve it, and we ought to be giving it to them. So I have a lot of confidence in them, but I will grant you that they are constrained. In our time, we had a clear goal of wanting to get to the moon and back in the 60s. In the decade, as the president said in his Massachusetts accent, but they probably could have stretched that to mean 1970 with a little interpretation. But nevertheless, we felt that we had a real urgency associated with the program, and today there is not that sense of urgency about it. So it's not an imperative, it's a valuable and important thing to do, but people don't feel like it is the most important thing we're doing, and they don't feel like we have to get it done by some particular date. And we are more prone to nitpick and review and legalize, or legality-wise, a lot of subjects that in our day, junior guys could decide and get on with it, and now it takes a considerable amount of review and approval by various kinds of management, And some of that is a reflection of the world that NASA lives in, especially as it is reflected in the conservatism that exists, risk-averse that exists in Washington, D.C. So I'm afraid these honorable, smart, tough guys have got a tough road, tougher than the one we had in a sense, and they're struggling with it, and it's probably going to be with them. I don't see that changing anytime soon. Yes, sir.
Larry Young, thank you for the inspiring look back, as well as for all you and your colleagues contributed. So much of the success of Apollo was attributable to training and simulation. And as we look ahead now to returning to the moon, there is a question as to whether it's still appropriate to go through, for example, a new equivalent of the lunar lander training vehicle, with its benefits, and I talked to Walt about that the other day, but also with its risks. Could you comment on that?
Are you talking about a trainer that's an actual flying machine?
Yes, the flying machine.
Yes, there is a debate going on in NASA. We had a flying machine. I'm embarrassed to tell you, but it looked like a metal bed frame, and it had an engine strapped on the bottom and some thrusters around it, and it was pretty ugly. As a matter of fact, two guys had to eject out of it, one of them being Neil Armstrong. So, but the crews, to a man, I think, and especially Neil, were very, very adamant that that kind of training was very essential to landing on the moon like they did. Today there's a debate as to whether the program and the system could get by without that kind of a training vehicle. To my knowledge, the discussion is still going on. I don't stay close enough to know whether they've settled it or not, but I suspect that they're going to end up with something. It'll probably look better than the bed frame that our guys flew on, but I expect that we'll have one.
But in your opinion, going back to Apollo, it was worth the risk?
Yes, yes.
Hi, Marcelo Vázquez, NSBRI. Fantastic talk. Thank you very much. Returning to the first question about the risk, and I would like to know how was the perception of the radiation risk, in particular solar particle events, during those early missions on Apollo. I have the opportunity, privilege to meet Mr. Rose. I think Mr. Rose was involved in the radiation protection.
Rose. Yes.
And I would like to know your take on what was the perception from mission control about the radiation risk.
It was you're referring to the radiation environment and the solar flare environment, which was at least it seemed at the time to be a little unpredictable. But yes, it was a real environmental concern that we had. We recognized that we had to do all we can to protect against it. We had kind of early warning systems set up so that we would, whenever people thought there were going to be flares, we would know about it. We had dosimeters and other things on board to measure in case we actually got to the point where there was a dose coming. And we were a little bit fortunate in that we flew missions that were relatively limited in duration, unlike the space station and shuttle flights the space station flights of today, and even the shuttle can stay up there now almost 3 weeks. So they're longer and longer durations, and we probably know better how to model solar flares. Maybe folks in this room know better than I what that stands like today, but we were alert to that as a possibility, and we knew that if we had one that was bad enough, we had to do everything we could to get the crew back safely. When they're in orbit around the Earth, you know, we had regularly intervals at which we could bring the spacecraft down. It was a little tougher when we went out to the moon. But nevertheless, we were aware about it and we respected it because it was something that could not be ignored. Yeah, Walt.
Comment and a question, Glenn. Yes, today's LLTV, when they build it, will look better because everything today has to look better. But I want to thank you for your description of the 5 giant steps to the moon. It's the first time I think I've heard you put them that way. Question for you. On Apollo 8, a thought that I've had, and I've never really checked it out with any of the flight directors, and I should have. Before we went to the moon, there was a lot of talk in the media and all that about break-off phenomena and being out of touch with the Earth, etc. And at the time, none of the flight crews ever felt any of that kind of stuff. But as time went on, I came to the conclusion, maybe wrongly, maybe correctly, that it was a big decision for management and flight directors, they weren't the ones doing it. We never gave a thought to it. But they were having to commit somebody going outside of the Earth's gravitational attraction for the first time. Was that a factor in your thinking at the time?
It probably was an environmental factor, Walt, but I mean, I don't think we knew what else to do with it. Fortunately, we were sort of in our 20s or barely out of them, so we were not inclined to wring our hands a lot or to be, you know, what if this and what if that. We dealt with them, but we didn't spend a lot of time unnecessarily worrying about them. It was sort of okay, yes, we recognize that, but it's time to get on with it. A good example is Apollo 12 had these big lightning strikes come out, you know, when the shot went up into the clouds, triggered the lightning, and it came all the way down through the ship, through the rocket, and through the plasma that the exhaust plume represented to the ground. Well, you can imagine what that did to everybody, especially seeing it. And then the spacecraft reports, and the spacecraft was all fouled up, fuel cells were off the line, the gyroscopes were spinning around. It was a mess. But the point of the story about the 20-year-old mentality was, we got this thing in orbit, we went through every check that we could think of and every check that we knew of, and the spacecraft worked out just fine. It is possible that there was something sneaky hidden somewhere, but if there were, it would show up sooner or later, or it wasn't there and it wouldn't show up. So I remember Jerry Griffin was on the console deciding to give them the go to the moon, and at some point we looked at each other and we kind of did this, you know? As far as we know, it's working. We don't have any reason for stopping, so we go.
Well, to follow up, for flight crews, you make those decisions, you're making decisions about your own life, and I think that's a relatively easy thing to do. I've come to have great appreciation over the fact that flight directors, flight controllers, much like Steve Bales on Apollo 11, you were in a position of having to make a decision on somebody else's life, and I've always felt like that was much more difficult than just doing it about yourself.
Yes, it is difficult, and we're aware of that, Walt, but I would also observe that there's lots of people in our society that makes decisions about other people's lives. I mean, you served in the Marines, and you know what officers have to do in that environment, and so on. So anybody that does that, doctors right over here do that every day, and you got to admire people who have the courage to step up and do that. Some people do it for a living, actually, and you can't have anything but respect for them. Okay, George, am I okay? Oh, we got one more. Jeff?
You sort of alluded to this, the age of the flight controllers, and I think it's a nice transition to the next panel on education. You know, it is amazing to realize the average age of mission control in those days, and you know, you've seen how mission control evolves, and you sort of made one reference to it, but I wonder if you could, I mean, is that going to be a real impediment to trying to take the risks and the decisions that need to be made this next time around?
You mean the fact that they're older?
Yeah. A lot older.
Well, I know a lot of the people that do that, starting in the family, and they seem to be fine with it. They seem to be fine. I would tell you one thing about the control center today. When my day, we had all ugly men. Now we have at least half, usually, women in the control center, and they add a certain class and upgrading to the team. And no cigars, right? You can't do that. So. I think it's been a big improvement. And we, by the way, added a lot more brain power that we didn't have before, too. So I think all in all, it balances out. But I think the people today are just as good in terms of attitude and probably better in terms of preparation and the tools they have to do their jobs than we had in our day. We were just, as I tell my son, Iron Men, but we had these old rickety wooden ships. But they have great things today to help them. George.
I would point out that Glenn Lundy's son is a flight director today, so he is one of those young people working there today. So, Glenn, thank you very much.